Good morning, everyone, and welcome to our webinar on Abaqus 2018 updates. I hope you guys are doing well. Just to give you guys a brief summary, this webinar will be about 30 to 40 minutes long. At the end of the webinar, we're going to have a Q&A session. If you have any questions, you can let us know at the little Q&A tab that you're going to see at the bottom of the screen. And we'll do our best to answer all the questions at the end. This webinar will be presented by Nishant Kumar, who is the Senior Engineer at VIAS. And now I'm going to give control to Nishant and he can take over. Hi, Nishant.
Thank you, Kanis. Yes, hi. So hello, everyone. This is Nishant Kumar, and I also have Ali Solak with me to answer any questions which will be probably related to licensing and all. So yeah, let's get started. I mean, while we get started, I will like to say sorry once more that last time we had some technical issues, but and so. Thank you very much to all of you to come back and join us today. So, I mean, the agenda remains same what we saw last time. We'll have a quick overview of the company, and then we'll go to Abaqus 2018 update. And at the end, as Kanis mentioned, that we'll have the Q&A session, and where we'll try to answer all of your, or most of your questions, what we can. So, we are a team of engineers from different, having experience from different industries like energy and processes, life sciences, industrial equipment, transport, mobility, and etc. So our head office is in Houston, but we also have presence in Chicago, Cincinnati, San Francisco, and Detroit, and other parts of the United States. We are also the solution partner of Dassault Systems, and that's why we are here to present the updates in the latest release of Simulia products. Mostly Abaqus will be talking about. We'll also have a couple of discussions on iSight, but we'll not be talking about FEA and Tosca. I mean, within these 30 minutes, we are trying to tell you all those important updates which have been done in the last 1 year. So you can imagine it's not really possible to present everything, and that's why we have very limited things to be which we'll show here, and you always have the documentations and all to go through. And anyway, so and that's why we are only presenting Abaqus mostly, and something on iSight. We have technical capabilities, as I mentioned, from versatile fields of engineering, right from component design to automation and electromagnetic systems, composites modeling analysis, fatigue, fracture kind of simulations, optimizations, both parametric and non-parametric kind of optimizations. We also have capabilities along with FEA into CFD and thermal kind of analysis. So in terms of value proposition, we are very committed to our client successes. Through technical excellence and innovations, we tend to go out of box to help our clients in getting their targets achieved with high accuracy. We have domain knowledge in FEA and expertise in versatile fields of engineering. We can also review your existing simulation workflows and provide you a feedback if it is required for any enhancements and improve your efficiency. We provide customized and standard trainings in-house, on-site, and online. And we also offer software development services for Abaqus, including any kind of plugins we may require, any kind of automation scripting you may require, and all. So yes, to get to know that what type, what all standard trainings we have scheduled for the year, you please go to this site and have a look. But if you have any request for any kind of customized training, do let us know, which you probably will not find in this list, but we can always schedule it for the requirements of customers. We do have open house days on every first Friday of each month. which is I find it very excellent way to kind of learn Abaqus and learn new features, even though you already know things about Abaqus. And there you can actually come with some of your problems, and we can try to advise you that how various things may be done to improve it. Um, Right. So let's go into the updates straight away. As I mentioned, we are trying to cover things done in a stretch of 1 year. So my intention is to show you very briefly that what are the things now available, the new things available in the latest release. Uh, and if you have an interest, the documentation has got all details of it. You always have our email IDs to ask us, and we'll be very glad to help you and guide you with any kind of new improvements for which you may need more detail for your work to be done successfully. So the first improvement which we have, or the new feature we have in 2018, is unsorted node set support. I believe that you will start appreciating this enhancement when you will start using it really. You have this option of adding nodes in the already created set by picking individually or along geometric edges, or the usual standard ways of adding nodes into it, or by entering labels manually in the table. You can also use a Python expression in order to order part or all the set of according to the parameters, for example, labels or coordinates. Uh, I mean, this improvement has got a lot of side advantages, which you will see when you start using it. The one thing is that you can now sort these node sets in different ways, and like in different groups, if you want. You can select these different rows and move them up and down, and edit any of them, sort them in a certain way, like ascending or descending order if you want. As I mentioned, that there will be a lot of side enhancements or related enhancements of these unsorted node sets. And one of them, which I find really useful, I mean, we have been struggling with this thing in the past for many projects, I remember. I mean, it was there, but it was available in input file. We had to do things in the input file, but now it's available in CA. So what we could not do prior to 2018, that whenever we tried to create an equation, each reference set after the first could only contain a single node. So the first set could have multiple nodes, but every set after that could only contain single node. And one reason was that the nature the sets were created, those are not guaranteed sorted in a certain way, which we probably would require to. So, but with this new enhancement, that restriction is gone, and you can have multiple sets with more than one nodes in each set, and then you can define equations for those node sets. Right. This is again a very interesting and very useful improvement, which is now when you define the bolt load, you don't need to specify, first of all, the inner surface, which earlier you had to, and second, you don't need to specify the axis. You simply select the surface, and the bolt load is applied at the location. So you have to select another location where the partition will be done automatically, an interior surface will be created, and the bolt axis will be actually along the axis of the cylindrical volume which you have selected. Yes, you're no longer required to select a bolt axis. I mean, it will be normal to the interior surface which will be created, but I mean, mostly what I like about this improvement is that now you can define that bolt loading in part level. So now you have a part, and using that part, you may have like multiple bolts in the assembly. So you don't have to specify that bolt load for each and every instance individually. You specify that in the part level, and every instance of that bolt will have that bolt load defined. You're right. So the star field option was always there, but it was available in the input file. So you could specify some kind of field variable within input file, and then you could kind of change certain parameters, for example, material properties, based on the values of those fields. Now that's available within CAE. So, and there you can actually specify it using a certain value. So you can directly specify the value, or you can specify it from by reading results from ODB. You can also specify using some analytical field, and of course you can specify using a complicated formula which you may have by user subroutine. Right, yeah, so I mean, this is what I was saying. You can actually specify using constant through region, gradient through beam section, define that shell beam field points, and you can, from an ODB, you can specify the increment at which to start reading the field, and the end increment or step at which you stop reading the field. About the initial condition, you can not use subroutine specification, and you cannot use the amplitude option for direct specification or analytical field. So the initial condition has to be a fixed value, or a certain value from ODB. But of course, you can always change this in the history or in the analysis steps as you define those steps. The view cut based free body forces were not available for composite solids prior to 2018. Now those are available for solid composite elements. Now CA calculates an average stress variable from solid composite stress variables, and then it extrapolates to the nodes, and it proceeds as for homogeneous solid. We have a few enhancements, and very interesting enhancements in explicit. We have a few new elements included in explicit, and one of them is C3D5, which is a linear pyramid element. It is isoparametric 5-node pyramid element. It has 5 integration points without hourglass control. I mean, you don't really need hourglass control on this kind of element. And it is identical element formulation as used in standard. So it was there in standard, but it was not available in explicit. But now we have it. Explicit didn't have the C3D4H elements prior to 2018. Now we have them. So the element formulation is different from that we used in Abaqus standard. And as we expect, this element won't lock for incompressible materials. Both these elements, C3D5 and C3D4H, support all of the loadings, material behaviors, boundary conditions, supported by the existing break, wedge, and tetrahedral solid elements in explicit. One thing is that you can actually import these elements from explicit to explicit, and like prior, you could import it from standard to standard, but you can't yet import it from standard to explicit or vice versa. So hopefully in future, this limitation will also be gone. And as I was mentioning, C3D4H won't lock for any hyperelastic or materials or any kind of plasticity you may have in the analysis. And you can see that here, that these deformations are pretty large. I mean, here you can imagine that the deformations are kind of constrained because of the locking nature of C3D4 element. But these are close to what we expect and what we get from standard. So now the results will be much better. Right, we have got a few enhancements in CEL and SPH, which are again going to be very useful. If you have used CEL, you may have seen this kind of issues in the past that, for example, if you have to model certain say you are pressing this blank from a die or something on top, then you could not specify a boundary condition at this interface. And the only way to do that was actually by I wanted to show this animation while I talk. So yes, I mean, the only way to specify the constraint at this contact was to define a contact with a rigid body. And but now you can actually constrain the motion of the material on the CEL boundary to not to move in a certain direction. And that actually, so it will actually stop the flow along that direction. It will kind of make the velocity zero in that direction at that point, like what we see in CFD simulations. And that actually will give you a better result, because in this case, you could see that you will see some kind of vertical movement in the blank here. But here it's actually behaving like fixed at the bottom. Right. In SPH, we have this new enhancement, which is again very useful. I remember in the past, I have seen people struggling with this kind of analysis when they wanted to model, when there's water or something is forced into a structure. Then we actually had to model a bulk of SPH elements at the inlet and then let it and pressurize it to enter through an orifice. But now with this enhancement, you don't need to do that. You can actually have a source like what you see in CFD, that you can have a inlet where SPH elements will keep on coming without any. So I mean, you can actually specify an inlet boundary condition, which will ensure that all these elements kind of gets generated at that surface and enters into the domain. And similarly, at the outlet, once these elements cross the outlet, they will disappear. So that actually is a very useful enhancement. I mean, personally, I'm very glad that this has been incorporated now in Abaqus. Right, we have this field output filtering for most of the outputs in Abaqus, as you know, but we did not have it for principal strain values. Now these are available for principal strain values, and these are available for the minimum, intermediate, and maximum principal strain values. These are not available yet for the first and second invariants, but hopefully in future we'll have them also. Right. People who have used XFEM and who tends to model propagation of cracks will really like this enhancement, that the newly created surfaces in XFEM, when the crack propagates, will now be included in the general contact. And that means, to explain that with an example, I mean, you can imagine that if you have an existing crack and you press a wedge into that crack and try to and let the crack grow, then the wedge surfaces will actually come in contact with the newly created surfaces because of the progression of the crack. So that kind of enhancement is again going to be very useful and well received in the by the users who have used XFEM in the past and have been asking for this enhancement pretty much in the past. Right, we have again another enhancement in explicit about dynamic feature edge criteria. You know, when you specify contact in explicit, you can specify the edge to surface contacts, and the definition of edge is based on the angle the two surfaces create at that particular intersection. Now, whatever edges are included at the beginning of the simulation remains constant. Till 2017 version, we have seen that these edges remains constant, and newly created edges because of a simulation like this paper fold, where as the paper folds, a lot of newly created edges will come into picture, and these edges will also tend to contact with existing surfaces or existing edges. So this new enhancement will make sure that all newly created edges are now coming into contact or are included in the contact definition. And you can see, I mean, this really is going to be very useful. For example, when we started this simulation, at the beginning, you can imagine we only have 4 edges into the contact domain. But as we move at a point towards the end of probably the analysis, we have almost 62% increment in the edges, which will come into the contact, or which will be included into the contact definition. Right, in explicit again, you can now define friction coefficients using 2 ways, either surface properties or the usual contact interaction properties. With surface properties, you specify the friction coefficient specifically for a certain surface, I mean, which is basically a function of the material properties at which the surface is lying. And so, and if you have two different surfaces coming into contact which are made of different materials, then a certain formula, for example here, 1.3 minus 0.3 into mu I by mu j into mu I will be used as the friction coefficient between these two surfaces. Now, this is well researched, and this formula has been taken from certain literature, but I will always encourage our users to go through the literature and kind of get an idea that this is exactly doing what they are expecting the surfaces to do. If you have defined both surface and contact properties, then the contact property will take the precedence, and the surface property will not be used. But you can reverse the precedence if you want by specifying the command star friction. This command is not available in CAE. You have to do this in input file. Quickly, linear dynamics have been getting improved in terms of performance since last few releases, and the trend is going on. Now in 2018, we have again a lot of enhancements and new features in linear dynamics, mostly in terms of performances. And there are new features also added into the linear dynamics. So if you are interested, please go through them. A few of them to read out. Now Abaqus SimPack integration is included, acoustic metal damping is included, which is very useful for people who are doing acoustic analysis. We have also seen that inertia relief performance was also highly in demand in the past, and that's also included now in Abaqus 2018. So this is a summary of those enhancements for linear dynamics that AMS eigenvalue extraction analysis has been done. Hybrid CPU GPU model frequency response solver now can use multiple GPU devices. Till 2017 you could only use one GPU, and so on. So if you're interested, as I suggested, go through the documentation and do let us know if you need more detail about any of the enhancements in these features. We have a new element in to model continuum shells. This is called continuum solid shell element. It will have the it will model as shell, but the stress state in this elements will be 3D, which is and this element was actually in high demand. People were asking for this, and so the good news is that this is now available. And another thing is that in the CSS elements, till 2017X, all the normals, to show you here, you'll see the normals were actually defined at nodes. So if you have a surface like this, a circular surface like this, then the normals were actually radial, which does make sense. But those were not normal at the mid surfaces or the surfaces of these elements. Now these normals are actually projected at the mid surfaces of elements. And one advantage is, you can imagine, is that ensures that less number of elements can actually be used along a curved surface. And these elements again are radial as well as normal to the surface of the element. The heat transfer element we had, D3D8, was a full integration element till 2017. Now it is also a reduced integration element. So that means the calculation is not done now on 8 integration points. Rather it is done on only 1 integration point. And of course, that means a very high improvement in the performance of these elements and the analysis associated with these elements. In terms of accuracy, it does not make any difference. The results are same for both the reduced and the full integration heat transfer elements. We have a new element for coupled temperature displacement gaskets, which will allow you to model the gap conductance and basically the heat transfer through the gaskets in a couple thermal stress analysis simulations. Hmm. Yes, all these material enhancements which you see here were actually introduced in 2017. And if you look carefully at all these enhancements, these were mostly introduced to enable Abaqus to do additive manufacturing kind of simulations. All these enhancements are improved in 2018 by adding new features and new techniques to improve the performance. If you are interested in any of these, go through them. I have not included the details of these enhancements, mostly because of the time constraint we have. But again, I mean, these are available in 2017 also. If you're not aware, please go through them and yeah, let us know if you have any interest in doing the additive manufacturing kind of simulations. As I mentioned, I do have a couple of very interesting enhancements within iSight. So the first one is that in iSight, we have a new graph called scatter bubble graph now. This graph will actually has the capability of plotting a 5-dimensional kind of thing, or maybe a 6-dimensional kind of thing, where you have x, y, z as 3 coordinates, and other 3 variables can be plotted using the color, the size, and the type of the glyph in this bubble graph. So, and another enhancement we have is something called adaptive DOE algorithm. This is done on top of the existing DOE run. So for example, you have already done a DOE and now you want to run a few other cases to get some sort of optimization out of it, then adaptive DOE is going to be very helpful. It is packaged as a new optimization plugin within iSight. And so what it does is it basically tries to fill the design domain space with keeping the constraints, of course, in the mind and the objective which you want to achieve for the optimization purpose. It reduces, and the good thing is that if you follow this method, it will reduce those noises in the optimization process. I mean, because it's not going to move away from the points from where it needs to achieve a certain constraint it requires. So right, we are almost done. We are actually done here. As I mentioned earlier, we are very serious about supporting our customers, and we have now this open house free first Friday thing. We can also visit on site if required. And yeah, I think I'm done. Thank you very much. If you have questions, the platform is open for questions. Please ask us. I think I have a question here. Sounds great. Thanks. Okay. I am not sure. So, Kanis, do we have a recording for this? Maybe we can send a PDF of these slides if required.
Yes, I am recording this webinar and I will be sending it out to all attendees shortly. I think we have a question here. Are there any examples for using the new continuum shell element? Can we answer that, Nishan?
I'm not aware of, but the thing is, whenever any element is included within Abaqus, it is always verified, and that verification example is always included within the documentation. So the documentation should have it. We can confirm it and then answer that.
Are there any other questions? Guys, please feel free to ask us. We're just gonna wait a minute or so to get some more questions and then we can end the webinar. Okay, guys, it seems like we don't have any questions anymore, so we will be concluding this webinar. Thank you so much for attending, and I will be sending out a recording shortly. Thank you and have a great day.
Thank you all.